G'day everyone, I'm Matt and welcome to CEW.Manufacturing. I'm just doing a really quick video today about this trigger clamp press brake that I've made up. Just there's a bit of interest generated on Reddit on our functional print. So I'll show you how it all works, what the components are. They're pretty simple, you can see it, and just a demonstration of it actually bending some stuff. So for those that are actually normally on my channel, you'll notice that I don't have a vise or anything in any stage, and I normally use what I call as a portable vise, just to push things in and like vice stuff, that's the technical term. And I needed to actually bend some metal for something I'm working on that I haven't shown on the video yet, but I'll show you at a later stage. And it was only a small bit, so this is only 1mm thick steel, which is I believe 19 gauge, to use old school American terminology, 1mm steel. So I needed to make a little a vice brake. I was going to buy a vice, and I'm still going to buy a vice, but just not right now. Instead, I thought about it and went, you know what, I have a 3D printer. I've seen people use 3D printed tooling to make sheet metal brakes on hydraulic systems. So surely I can make something that'll work on one of these and we'll still achieve what I needed to achieve. And this is what you see. So you can see the two parts of the die here. We have what I assume is the male and female. Most engineering terminology uses gendered parts. They go together like so. This part here is about an 86-degree angle, inclusive angle in between, which allows you to bend slightly over 90 degrees. So with control, you can actually get it to bang on 90 instead of being stuck with spring back, where you bend it to 90 and then it comes back to 92, 93. The male part is slightly sharper again, just so we can get the throat or the very leading edge of that part of the die right up into that corner to give it a nice sharp bend. This end here fits onto these quite nicely. So all we do is we just put it on like that. Give it a bit of a push home. Same with that side. Push it down, and that's on. That's not going anywhere. So now we just take our steel, put it in between, however you want to hold it. Let's go for this end down here, just for fun. And now we just have a squeeze. And simple as that. Bob's your uncle. You got a bent bit. It bends a little bit better down this far end than it does at the other end. The last 10 mil or so is not quite as good, so that's all I do. Just pull it back out, put the steel in, the other side, and we just go give it another bend. There we go. We have a nice bent part, and one more for fun. So it's not actually particularly hard to do. This whole thing works pretty well. You can see I've just put a couple of bends in this steel without much effort right now. The only real negative to it is that because this end of the clamp here is adjustable and can be switched from this end down to this end, it's only held in by a single pivot point and a loose fitting on this. So it actually kicks back a little bit and you don't get a perfectly vertical mating surface between the male and the female parts of the die. That's why you have to turn it over to the other side if you want to get a perfect bend, because you get a larger radius here. So we can just have a look at that. Than you do on this side here when you first do it, but then when you put it back in, you push it home again. We end up with a much nicer and even bend across the whole thing. So that's the only real negative drawback about this. It's about 200 grams worth of material. It's 2.4mm wall thickness and 1.8mm top and bottom thickness, like 30% infill. So it's a nice part, it's nice and simple to make, and it's actually quite useful just for bits and pieces that you're doing in your workshop. Yeah, guys, thanks for watching. I hope you enjoyed something and got something out of this. There's more 3D printing stuff to come.